from week 12, where I will be deriving the equation, then solving it. But you can still ask doubts. But within 2 days, I will be uploading the solutions in the portal. So if you still have doubts, you can ask in the Wednesday's mock session.
Oh, okay, thank
fine?
you. Yeah, thank you,
Yeah.
Professor.
Till week 11, practice assignment discussions has been over, right?
Yes, ma'am. Only the week 12 is left.
Okay. So yeah, is my screen visible?
Yes, ma'am.
Yeah. Today, basically today we'll be covering having two parts. One is we'll be solving problems related to all the major concepts from week 1 to week 12. The other part is we'll be revising each and every concepts from week 1 to week 12. What shall we do first? Either we'll solve problem first, because today we have 2 hours, right? So we will be solving problems, then revising the concepts. What do you want to do first?
Ma'am, can we first solve the week related problems and the discussion for week 12, because it has some formulas which are given by the.
Yeah, Gauranj, I can understand your concern for week 12, but this session is purely for revising all the concepts from week 1 to 12.
Yes, ma'am.
So,
we can start with week 12 and end, and then go on till the.
Okay. So see, there is one question from week 12 I have taken. So yeah, we can start with this question. Is it fine?
Yes, ma'am.
Gauranj?
Yes, ma'am.
Yeah. So yeah. So we'll start with this question, and maybe I will try solving 1 or 2 questions from week 12. Then I'll okay. Yeah, sure. Yeah, if you see the given question, consider the given circuit where switch S1 is opened at t is equal to 0 and S2 is closed at t is equal to 0 as indicated. Assume the switch S1 has been closed for a very long time and the capacitor has reached the steady state. Answer the following questions. So yeah, you guys try solving this for 2 minutes. Then we'll start solving it together. Okay. So yeah. So basically, first we'll see what they are given in the question. They are given there are 2 switches, right? First we'll note it down. What are the switches? Switch 1 and switch 2. There is one capacitor, there is one voltage source, and there is one current source. So whenever we are given with any type of questions from week 12, we usually start in this manner. Okay. First we will understand the question. So what they are given, given the switch S1 is opened at t is equal to 0 and switch S2 is closed at t is equal to 0. So this is the condition at t is equal to 0. S1 is open, S2 is closed. But before t is equal to 0, they are given this condition, that is, assume that the switch S1 has been closed for a very long time. So before this, S1 is closed for a very long time and the capacitor has reached a steady state. So basically, here the case 1 is, initially S1 is closed, and S2 is open. So the voltage is 5 volt and there is no resistance here, right? And the capacitance is 0.1 farad. So what is the, and they are given S1 is closed for a very long time. Now what is the voltage across this 0.1 farad?
It will be 5.
5 volt. 5 volt.
Ma'am, you are not clearly audible.
Is 5.
Ma'am, your voice is very loud.
Am I audible now?
Ma'am,
Now is it clear?
Actually, ma'am, there's a lot of
It's
disturbance.
still cracking a lot.
Now is my voice clear?
Yes, ma'am, it's clear now.
Yes, ma'am.
Yeah, okay, thanks for telling that. Yeah, so yeah, see, we know, right? When, okay, we will start from this itself. When there is a 5 volt capacitor and when R and C are, okay. So yeah, we will start from basics in this type of questions. We have seen this type of questions, right? When there is a step input given here, there is a R, there is a C. How do you find VC of t? Let me take it as Vm. What is the formula? How to find VC of t? It's Vm 1 minus
Then
e power minus RC.
1 minus
T
e
by
power
RC.
minus t upon RC.
Yeah, right. So when there is a step input, my output voltage will be going like this, and eventually it will be reaching Vm. So this is what we have learned in RC type of filters, right? So after a very long time, when it is switched on, my VC of t will actually reach Vm. So after a very long time, VC of t will be equal to Vm. So first part we are able to find it out as, so this is how we have come to this conclusion that after a very long time VC of t is equal to 5 volts. Now the second condition is at t is equal to 0, S1 is open and S2 is closed. That means at 0th condition, now my circuit will become like this. I0 is equal to 5 ampere, 10 ohm. This is my capacitance 0.1 farad. Now what is my VC at time is equal to 0?
5 volt.
Yes, it's 5 volts. Because I just, at 0th condition, my voltage across the capacitor will be 0 volts. Now they have asked, okay, again, I'll go to that page to explain you one concept. Yeah. Because of the voltage source, my capacitor has charged. At this point, I'm removing the voltage source. Then what will happen to the capacitor? What will happen to the capacitor voltage? This is charging. Okay. If I remove the voltage source, are you able to understand what I?
Yes, ma'am.
Yeah, it
ma'am,
discharges.
again, like, why it's 5 volts here?
Yeah, you want to know why it is 5 volts here, right?
Yes, ma'am.
Yeah. So that's what I have explained here. Okay, I'll explain it again. So yeah, if you see here, see, we have already seen in types of RC circuit, right? Here it is V, M, R, and C. Here there is a capacitance VC of t. When I give a step input, I know VC of t is equal to Vm 1 minus e power minus t by RC. from this equation at t is equal to 0, Vc of t is equal to, what will be that?
V of m.
V of m 1 minus e power minus 0. E power 0 is
1.
1 second. At 0, wait a minute. Initially, the Vc of t will be 0, right? Am I
Yes,
doing
ma'am.
anything in the...
What
Wait
was the
1
case?
second. Okay, sorry. Yeah. Now I got it. Yeah, Vm 1 minus e power minus 0 is actually 1 by e power 0. Vm 1 minus 1 by 1. So it is actually Vm 1 minus 1, which is equal to 0, right? Yeah. At time t is equal to 0, initially Vc of t is equal to 0. Then at time is equal to infinity, Vc of t will become Vm 1 minus e power minus infinity by Rc. 1 by e power infinity is 1 by
It will be
infinity, that
0,
is 1 by,
then it will
yeah,
become Vc of
Vm.
t is equal to
Yes,
Vm.
yes. And it is exponentially increasing. So how my graph will become is, this is Vc of t, this is with respect to t, this is my input. Let me draw my output with another color. Initially it is 0, then at infinite time it is Vm. So it is exponentially rising. Okay. And another point we have to consider here is the time at which it will become Vm by 2. What is that?
0.693 RC.
RC.
Yes, it's 0.693 RC. What if R is okay. Okay, 10k, 1k, 0. If R is 10k, I will take this is my response, 10k ohms. What if my R is 1k ohm? Will it be going like this or like this? Is it first case or second case?
It will
Ma'am,
be the fast case.
First case, yes. If the R is decreasing, my output will be more resembling my input. Is it clear?
yes, ma'am.
Yeah. So yeah, again when it is 0, it will actually be resembling my input very closely. So this is my Vm. If R is equal to 0, even though in this type of given type of circuit where only my voltage is connected with capacitance, there will be some minimal amount of wire resistance that will be there. So because of that, there will be a small gap here also. So this is how my actual Vc of t will be. So initially it will be 0, and going on at infinite times, my Vc of t will actually become Vm. Okay. So that's why here my 5 volts is connected to capacitance. Initially from 0, it will be going to 5 volts. So after a long time, Vc of t will actually become 5 volts. Now they have asked the question, what is the voltage Vc of 0 plus across the capacitor? That is, see, there are 3 times here itself. 0, 0 minus, 0 plus. If they are saying at 0 my switch is closing, 0 minus is the time that indicates just before that switch closing. If they are saying 0 plus, just after the switch has been closed. Just after the switch has been closed, no major changes will happen. Because capacitor will gradually only charge or discharge. So the 5 volt will be actually there. That's why here C of 0 plus is equal to 5 volt. Is the first question clear?
Yes.
Yeah.
Ma'am, sorry. So when the time is 0 minus, the voltage is how much is the voltage?
When 0 minus also it's 5 volts, right? Because they have said that the time period is a very long time.
Ah, okay,
Yeah.
okay, got it.
Yeah. They have said, see, I will take this point as that long time. So even if this is 0, then the next point immediately to is the 0 plus, and the next point immediately before that is the 0 minus. So in all these points, it's still Vm, right? I hope it's clear.
Yes, ma'am.
Yes, ma'am.
Yes,
Yeah.
yes, Professor.
So yeah, so that's why it's Vc of
Uh,
0 plus is equal to 5 volts. So the first case is
Anna?
over, right? Yes.
At 0 minus, how do we get VC is equals to 5 volts?
Because if you see in the diagram, they are given at time is equal to 0, the switch S1 is opened, right? That means at this point, switch is opened. That means at this point, I know it is Vm. Just before that point, you see, for a very long time, it has been like maintaining Vm, right? At infinity, it is Vm. Just infinity minus 1 will not make much change, right? 0 minus is a just previous time before 0. So it will be still Vm, right? So why do you think it's not Vm?
Okay, ma'am.
Yeah. Do you guys have any doubt in this why it is Vm?
No, ma'am.
Okay. So yeah, then. So yeah, next we'll go to the next part. That is the initial case which I have given. That is at t is equal to 0, S1 is open and S2 is closed. So my circuit will actually become like this, right? Yeah, this is plus and this is minus. Now, the first step in week 12 kind of problems is after you, now we have the initial voltage, there is a resistor value, capacitor value, and I naught value. First, we have to write the differential equation. Okay. I will take this as IC of t. What is the formula for IC of t?
C dV by dt.
C dV
Yes,
by dt.
C by dt, right? Now what C dVc is equal to IC dt. Now I will integrate both. Okay. What will I get? Initially, it's VDD to 0, whereas time is 0 to t. Or maybe wait, I will explain you how we are writing this integral step by step. Yeah, this integral step I will explain it again. So yeah, there was a capacitor, right? There was a resistor, then there was a current source in series. Let me take this current source as I naught, then this capacitor as C, then initial voltage I will take it as, that means Vc of t at time is equal to 0 is equal to VDD. This is the positive terminal, negative terminal R and C. I am taking the IC of t in this direction. Okay. Yeah. Now I will split the IC of t dt is equal to C dVc. First, they have said that in the question what they are given about the time, they have said that, what did they say? The switch S1 is opened and S2 is closed. And yeah, and we will, so actually basically the switch is in this condition. Initially, S1, S2. Initially, S1 is open for a long time, but S2 is closed. Then This is case 1. At case 2, S1 is closed and S1 is open. And this is also open for a, it is open. Look, okay, it's open. So yeah, I will take that it is open for a time 0 to t. Because they initially they said at t is equal to 0 only, like I am shorting this part. So my time is varying from 0 to t, whereas my VC was initially VDD. Then gradually it will get discharged to 0. So that's why I'm writing VDD to 0. Is it clear?
Yes, ma'am.
Yes,
Now,
ma'am.
yeah, please tell your doubts one by one.
Ma'am, we are considering a ground to the both ends. So if this connected to the wire, it is similar.
Yeah,
अगर
both, yeah. See, what you're saying is
अगर इसमें
like
वायर
this
से अगर
and
कनेक्ट भी करते तो वो
like this, right?
हाँ ये
But see, this is how I have taken positive and negative, right, of the capacitor because of the voltage. Initially, there was one voltage like this, and that was signed like this. Because of that, here I have occurred some voltage. That sign is plus minus. So my IC of t will not change whether I'm representing it like this or like this. Am I clear in this? Like, or
Yes,
is it
ma'am.
confused?
In fact,
Yes,
upon
ma'am.
integral, it will give a
my
negative value.
question is
Yeah, you can short
it
it
is
also.
similar, ma'am, because I always confused when I see that open circuit here. So I
Yeah.
think
Oh,
is
okay.
there anything different?
No. See, there you have to consider there is one ground to the whole circuit, right?
Yes, ma'am.
So yeah, or however I draw my circuit, whether like it is, I'm drawing it like this. Then again, I'm having another one voltage source like this. You have to find these are like points where it is 0 volts. Points at the same voltage means they are connected. Okay.
Yes. Yes.
Okay.
Okay.
Now, what will you get?
We'll get it as IC of t is equals to minus of C VDD.
Right. Now I have to find. Okay.
Plus, there will
I
be one
think we are
more
going right.
constant.
There will be one more. Yeah. Can you please repeat again?
There will be one more constant.
That there will be one more constant. Okay. Yeah, but here we have started with okay. You can do that also. Plus constant, and you can solve and find k also. That is one way. But in this question, there is no k. Even if you find k, I think
Yes,
it will
ma'am.
come as 0.
Yes, ma'am. As we are also
It will
doing
be,
definite integral. Yes, ma'am.
yes. So ICT is equal to, is it a 0 minus VDD? Right? Yeah. Minus C VDD. Now we are going to find the time. That is C VDD by IC. Now, what is IC?
Ma'am, 5.
Yeah, it is minus, right? It is in the minus sign.
Yes, ma'am. Minus 5.
Yeah, it is minus. T is equal to C. I can up. Okay, I'll take this equation to that page. Here T is equal to C is 0.1, VDD is 5 volt divided by IC is minus 5, because see IC is flowing in this direction whereas I naught is in this direction. It's minus 5. So already that is one. What is the answer?
0.1. Minus
Yeah,
0.1.
it's 0.2. Is it minus 0.1? Because
No,
there are
ma'am.
two minus sign,
Point
right?
one.
Here it is, yes. So it is 0.1 second. Yeah. Do anyone have any doubt how we derive this equation?
Yes, ma'am.
Ma'am,
I'm
while
not
writing
getting
the
this.
answer, sign convention is necessary because it is only representing the direction. And
Yes.
is it necessary to show that?
That, yeah. Wait, 1 second. I will explain it again because many of you didn't understand. So yeah, this is the circuit, right? There is this R, there is this I. C is equal to 0.1 farad, 10 ohms. I naught is equal to 5 ampere. I am taking IC is in this direction because I am taking this direction because the direction of plus, because see this voltage. So this capacitor will acquire the voltage in this direction. So since it's a capacitor, I am writing IC of t in this direction. Now, whenever we have a circuit, we'll start with writing the differential equation. For this, how we are writing the differential equation as IC of t is equal to CV dVc by dt. This is nothing but the capacitor's voltage formula. We know that Q is equal to CV. So dQ by dt is equal to dCV by dt. dQ by dt is nothing but the current flowing through the capacitor. Then C dV by dt. Okay. Then I am taking this integral to this side. IC of t dt is equal to C dVc. Now I am applying integral on both sides. Now there are two variables. Here it is time in one end and dvc in other end. At time, there are two times here. At time is equal to 0 and some time at the time space. Okay. Yeah. My at initially at 0, my dvc is to
5 volt.
find that, yes, my capacitance, because of that S1, it was initially charged and it reached 5 volts. That is Vm. Then, since it is a current, it is in the opposite direction, right? It will lead to the discharging of this capacitance. So gradually my voltage will drop to 0 at some point. Okay. And that time I don't know. So I'll take it as 0 to t. So my dvc is dropping from 5 volts to 0. This 5 is nothing but vc. Vc or like initial voltage. I will take it as vcc or vdd, whatever. So if you see that integral 0 to d, this is vcc to 0. Now are you clear with the integrals, how we are writing the integral? Now
Yes.
Yes.
then integrating it, IC of t will come out. Only integral dt is there. That will become t minus 0 is equal to c is a constant that will take out. It will become vcc 0 minus vcc. So it is minus c vcc IC t.
Ma'am,
Yes.
can you please explain the limits again?
Yeah. There are two variables here. One is dt, another one is dvc. The time is varying from 0 to t because the switch is closed at 0. That is the condition given in the question. So from 0 to some point in time we are taking. That's why we are taking the 0 to t. And we have found at this t point the dvc is vcc, that is 5 volts. And at some point it will be reaching 0. So I am writing it as 0. So dt I am integrating over 0 to t and dvc we are integrating from vcc to 0. Is it clear now?
Yes, ma'am. Clear.
Okay. Now if we write, we will get the equation. ICT is equal to minus C VCC. So that equation I will write here. ICT is equal to minus C VCC or VDD, whatever. Then from that I know IC is nothing but minus I naught because both are in the opposite directions. So t is equal to minus 0.1 into 5 by minus 5 is equal to 0.1 second. Now is it clear? Or do you want me to explain it again?
Professor, so the direction of current is chosen randomly, right?
Yeah, I naught is in one direction, whereas IC of t is in the opposite direction. See, IC of t at the end of the day is the direction of the current which I assumed based on the sign plus and minus. If you want, you can assume the direction to be in the opposite direction also.
Okay.
But you have to initially assume that it is minus. Now we are going to find the. Yeah, please, Sonal, do you have any doubt?
Yes. Minus, which means you mentioned that I have to assume that the current was minus. So
see, what I have done here is first I took IC of t. Why did I take IC of t in this direction is because at first, initially, I did not consider this I naught. I only considered this capacitance. In capacitance, based on the sign plus and minus, I just drew IC of t. This you can also draw in this direction. No problem. But you have to take the direction according to that. If you are taking, yeah, 1 second. Yeah. See, this capacitance voltage is in this direction. If I take IC of t to be in this direction, what is the formula of IC of t? It should be minus C dVc by dt. Only if I assume the same diagram, here it is plus and minus. If I take it like this, only then my IC of t will be equal to plus C dVc by dt. Is it clear now?
okay. Yes. Thank you.
You can feel the difference in these two sides, right?
Ma'am, can just scroll up the screen.
Yeah.
Okay, ma'am.
Yes. Now, they are asked the slope of the voltage. That means I will take VDD, the same equation, VDD I will take in one side, minus IC by IC into T. So here, VDD is, it is in the format Y is equal to MX, right? So here the slope is equal to minus IC by C. Here IC is 5 and C is nothing but 0.1. So it is minus 50. Now is it clear? It's nothing
Yes,
but
ma'am.
voltage by second because now next what they asked is what is the value of current I1 flowing through the capacitor? Yeah, they have asked at 0.005 second what is I1. If you see the circuit, I1 is this value, I0 is 5 ampere, right? At 0.005 second, which means it's after 0 seconds. After 0 seconds, this switch is closed. Whatever the current that is flowing is provided by this current source. But I1 is in the opposite direction to I0. So I1 is equal to minus 5 ampere. Do anyone have any doubts in this question?
So minus 5 ampere plus 0.05 upon 2.
Okay. No, can you please repeat again?
Like on the I1 would be the ratio of both of them or just the I1 value?
No, just I1 value. They have asked only the value of current I1 at 0.005 seconds. Why they are given the 0.005 second is after the 0 point only the switch is closing. So after that, what will be that I1 value they have asked? We know there is a current source there. Whatever in series with the current source will have the same value as the current source for current, right? That's why I1 is equal
Yes,
to
ma'am.
minus 5 ampere. Here we have to mind the directions. I0 is towards downwards, whereas I1 is in the opposite direction to I0. That's why that is minus 5 amperes. Then again, what will be the slope of the voltage across the capacitance if so this is the extension of this question only. The same formula we will use, but instead of I0 is equal to whatever current we use, we will use 10 ampere. What is the answer?
I'm gonna just repeat like what did you say? I didn't get it.
Now, okay. Is my question visible? Yeah. Here they have asked what is the slope of the voltage across the capacitor? Yes, what is the answer?
minus 100.
Minus 5.
Uh,
It will be minus
they have
5.
asked the slope, right? I minus IC by C. Here IC is 10 by C is nothing but 0.1.
Yes,
100, right? Okay.
ma'am, minus 100.
But IC is in the opposite direction to I0, right?
Yes, ma'am.
1 second. Yeah, okay. The sign I will check and tell you whether it is plus or minus. But other than that, this is how we solve week 12 questions. Okay. So whatever the circuit they are given, first if like try to write it like directly, whether we can see in this question at first part we have directly wrote that the voltage across the 0.1 farad is 5 volts, right? In the same way, if we can write it directly, you can write it. Otherwise, go for differential equation.
So like
Write the
ma'am, for
differential equation. Is the orange?
like ma'am, for these types of questions, like can we first make the diagram like when only one switch is closed, and then like can you draw another
Yeah,
diagram
yeah.
when like the other
Yes,
switch is
yes. That
closed,
will be,
and then
see, once
compare
you
both
write,
the diagrams so like we'll get a better image of the question.
yes, yes. Because see, initially when you are trying to solve the problems, draw the diagram step by step, write the conditions also step by step. Then understand the question first. Then try writing the differential equation. See, for this type of questions, there are only two ways. One is you have to go through each and every videos of week 12. In that each and every scenario, like capacitance with only current source, capacitance with only voltage source, capacitance and resistance with current source. Then there was a case where voltage source, current source, and a capacitance are given. So there were many types of derivations discussed in the lecture series, right? Have you guys watched the week 12 series lecture?
Yes, ma'am.
Yes.
Yes, ma'am.
Yeah. Either you have to go through each and everything and learn all the formulas. That is one way. But there are high chances you will get confused. There is another way. You yourself write your differential equation and try solving it.
Ma'am, just for this whole solution for this question once again.
Yeah, sure. But you don't have to get very stressed because um, in exam point of view, you will not get very complicated circuit based on this. In from this concept, whatever question you get, it will be like to test your knowledge on these concepts, not like how long derivation you can write. Are you able to understand? Like you will not be asked to write a long derivation and all. You will be just asked to understand most important concepts in this type of questions.
Then like ma'am, when like we should learn then all the formulas because like sometimes there could be an error like while making the equation by ourselves.
It's fine as long as you try, no problem if you make mistakes.
Ma'am, I have a doubt.
Yes.
Like while finding I1, we have initially 5 volts inside a capacitor, so it will also like use as a voltage to provide current or not.
1 second. I'll come to you. Yeah, can you please ask your question again?
Ma'am, while finding I1, in a capacitor have a initial voltage 5, so it will also give current as a, it is also used as a voltage source and give current in a circuit, or it will not.
Yeah, that's a very good question. See,
Yes, ma'am.
they have said 0.005 second. That means 0.005 can seem as a very small current to us, but it's actually a considerable amount of time. And at this time, my circuit is like this, right?
Yes, ma'am.
My capacitor and resistor are in series with the current source. So the current flowing this capacitor and resistor will be I naught. But the direction is not what we have to be worried about. The magnitude will be I naught. Now is it clear?
Uh, no, ma'am.
See, at this point, this 0.1 farad is having some 0.5 volt after removing S1. So yeah, you are telling this 5 volt may contribute some to this I1, right?
Yes, ma'am.
But this 5 volt will now discharge. And any component in series with the current source, you don't have to bother about it current, because at the end, only the current source will be the main contributor to the current.
Okay,
Even if
ma'am.
there is a voltage source which is telling 5 volts, is in series with the current source, and some network is given here, and this I will tell it as 2 ampere. What do you think is the current flowing here?
Yes, ma'am. 2 ampere.
Yeah, now it's clear, right?
Yes, ma'am. Yes,
So
ma'am.
whatever in series with the current source will have the current flowing through it as the current of the current source.
Okay, ma'am. Thank you.
Yeah.
Excuse me, ma'am.
Yes.
Ma'am, in the same question, like we're asked to find the value of I1 at time 0.0057. So, ma'am, if we are asked to find at infinity, then
Even after infinite times, if the current source is there, the current I1 will be minus 5 amperes, right?
because like I1 is in the opposite direction of I naught.
Yes. So it is minus 5 amperes.
Okay, ma'am. Thank you, ma'am.
Yeah. Because see, these type of questions, we are considering this I as an ideal source, right? What is the characteristics of a current source? Whatever the voltage across it, the current given by a current source will be the constant. So, however time it takes, the current flowing through the circuit will also be 5 amperes. But in real type of scenarios, this current source will not be this much ideal. I hope it's clear. So yeah, once again, I will discuss this question. Um, so yeah, I'll go step by step, so it will be easier for you guys. Since first time when now we know, right, the second line is the first condition actually, and the first line is actually the second condition. So the first condition says that S1 is closed for the capacitor to reach the steady state. So my circuit is like this: 5 volt, 0.1 farad. This one I will take it as Vc of t. Now we know this 5 volt is a step input. So my output will be following something like this. This is at 0, this is at infinity. This is at 0, this is at infinity. So from the equation, I know Vc of t is nothing but Vm 1 minus e power minus t by Rc. So we know that at infinite times, after a long time, the Vc of t is nothing but 5 volts. So I have found that this is 5 volts. Now my second case is S1 is open, S2 is closed. So my circuit will become 0.1 farad resistor and there is a current source. This is 10 no, and this is 5 amperes. Once now I also know the 5 volt is the initial voltage across this. So what I will do, I will write a differential equation. That is my second step. That is write the differential equation. Then solve it. If you solve it, I will get an equation. I naught T is equal to C VCC minus VCC. From this, the voltage is the y-axis, whereas T is the x-axis. So VCC is equal to minus I naught by C into T. So this is the slope. This equation is the formula y is equal to mx. So m is equal to minus I naught by C. That I will use here to find the time. Okay, first I will apply T. Okay, yeah. This one is the third question for finding the slope. From this equation itself, I can find directly applying the values, I can find the T. Then this one is a direct question. They asked us to find the current. And then again, the next variation. Do anyone have any doubt in this question?
Excuse me, ma'am. Ma'am, in
Yes.
the second part, like, ma'am, if I apply I is equal to C dV by dt, so like, will I? So, ma'am, can you get the answer from there also?
No, you want to apply
I
T
is
is equal to C. I is equal to
C dV by dt.
C dV by dt. Okay. Then what will you apply?
Like, ma'am, then the dt would should be the answer.
No, I'm not understanding. Oh, in this like difference dV and dt value you will apply, then applying I and T, or you asking I will get the value, right?
Yes, ma'am.
Yeah, I think you will get. Please try and see. I'm not very sure, but you can try and see. But basically the same equation we are integrating and finding this, right?
Yes, ma'am. The I naught T is equal to minus C VCC.
Yeah. But anyway, see what the major problem here is, some sign changes we will not be able to, like, some doubt in the signs, whether it will be positive or negative, I will have some doubt. But at the end of the day, I know time is always a positive value. So what are like, I don't think you will get any problem with the magnitude here. I'm not very sure of the sign. Maybe I can try solving and let you know. But at least in this point, even if you try like this, you'll get the same answer, because time is always positive. Yeah. So yeah,
Yes,
since we
ma'am.
have solved one, yes.
In first questions, can we think like that? Scroll up. It's given the voltage after 0 plus, means positive 0. So can we think like that? It means after a 0 plus, we don't have the any voltage source. So the whatever the voltage which is before the 0 is 5 volt, and
Yes.
then that is stored in the capacitor. Then after that is
Yes.
also be a 5 volt.
Yeah, that is what going to be actually discharging after due to the current source. So initially my VC is 5 volt. Yeah, you can assume like that also.
I mean the last questions, will it be positive or negative? But so far as I know, the slope will be negative.
Slope will be negative. Yeah, that's what
Yes,
I
ma'am,
will
that will
make
be
sure and let you
negative.
know.
Yes, ma'am.
Is it 100 or minus 100?
Yeah, it should be negative, right? Yeah.
It will be minus
Okay.
100, I guess, also.
Yes. Maybe I'll change the question to if IC is equal to 10. Yeah.
Thank you, ma'am.
Yeah. So yeah.
Ma'am, in these types of questions, like, is there any method to like decide which is the case one and which is the case two, like as you showed us?
No, basically, see, in the questions it will be in the like in some order which you can be able to understand only. In this question is little bit complicated, but normally like they would have given initially the switch has been closed for a very long time, then switch 2 is open for a very long time, then they will give the next condition. It will not be very confusing like this one. Okay. Also, they will also use the diagrams to represent, like they'll be giving it like this. This is for switch 1 and this is for switch 2, and this is how switch 1 is, and switch 2 will be like this, like this. So this will also be some easy representation, no? It
Yes,
means
ma'am.
you have to, this is a case 1. S1 is open and S1 is closed and S1 is open. Then this is case 2. S1 is closed and S1 is open and S2 is closed. And this is a case 3. S1 is closed and S2 is open. So that either they will give it in this way, or they will be writing it like switch on is like in 2 or 3 points they would have written. So these are the two cases how they can ask questions.
Okay, ma'am.
Yeah. But also you don't have to very much stress about this week 12. But better understand all the concepts. Like you go through the lecture videos again and again. There they are given many key points like what happens when a resistor is in series with a current source, or a resistor is in parallel with a voltage source. Like those are the key concepts in this week 12. Like that you understand it more carefully and clearly. Okay. Like basic concepts, be clear with it.
Hello, ma'am.
Yes.
Which week or which topics contain more portion of the end semester?
Yeah. See, as you mentioned from day one, this is ESTC. So the major focus is on the electronic circuits like KCL, KVL, Ohm's law, then finding the equivalent resistance, equivalent capacitance, equivalent inductance, then superposition principle, Wheatstone bridge, then concepts like superposition, Wheatstone bridge, then yeah, then finding that bit from the bit rate, finding the time taken to, so these are the questions, right?
Okay.
Mostly be clear with the circuit types of questions,
Okay, ma'am.
because their weightage will be very more. So yeah, now we'll come to the first question. So if you see this circuit, in the circuit shown below, they are given R is equal to 5 kilo ohm and C is equal to 10 micro ohm, and voltage also they are given as 5 volt, right? 5 kilo ohm, 5 kilo ohm. Capacitance is 10 microfarad, 10 microfarad. We have to find the time constant. What is time constant?
50 millisecond.
Yeah, it's 50 millisecond. But tell me the formula, no? How to find time constant?
R into C.
RC.
Yes. R is nothing but the equivalent resistance and C is the equivalent capacitance. Here, what is the equivalent resistance?
Ma'am, 2.5 kilo ohm.
Yes. Into 2 into 10 microfarad. Right?
Yes, ma'am.
Yes, ma'am.
Now, the next question is with reference to the circuit shown below, we have to find V0. Tell me the answer now. What is the answer for V0? V naught. Try to solve it in like easiest way. Yeah, you can try solving any method. Tell the answer and also describe the method in which you solved it.
2.
V naught is not actually 2. Point 0.5. 0.5 is right. Sumit has written. So 0.5 is right. So who has said to please look at the signs, know how the signs are given. Now tell me what is the total voltage between those 2 points, A and B?
0.
Yes. So I can actually change my circuit as 1 ampere, 1 ohm, 1 no, and V0 is here. Right? Now tell me what is V0 now?
0.5.
0.5.
Yeah. So this current actually be splitting into 0.5 ampere and 0.5 ampere since same resistance is present. Now V is equal to IR. I is 0.5, R is 1, so 0.5 volts. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes. So yeah, this type of question is also important. Finding the power, whether it is observed or delivered. Yeah, try solving and tell me. What is the first question? Power absorbed by the 6 ohm resistor. The circuit may look complicated, but it's actually, if you like uh, name the nodes and put it together, the circuit is actually simple. Oh yeah, the last answer, right?
Yes, ma'am. I got 0.68.
Okay. Yeah, did anyone else try solving for that? And what answer did you get? Yeah, you try solving this question. I'll tell you the answer for that question.
Now, please explain this question.
What happened? Okay, yeah. So I will try. I will simplify this question. Then it will be easier for you to solve. This is one common node, right? I will take it as B, A, and these are all another common node, right? So I will take it as B. So there is one A and there is one B. From A to B, there is one 6 ohm. From A to B, there is a current source pointing towards A, 7 ampere. From A to B, there is another one 8 ampere pointing towards A. So 6 ampere is covered, 8 ampere, 6 ohms is covered, 8 ampere is covered, 7 ampere is covered. Then between A and B, there is one 4 ohm and 12 ohm resistor. 4 ohm resistor, 12 ohm resistor. Now the circuit has been simplified, right? Now I will merge the current source and merge the resistors. A, B. What is the... Oh, okay. I will not merge, like I will keep the current source separate. 8 ampere, 7 ampere. What is the equivalent resistance? 6 ohm, 4 ohm and 12 ohm.
And 2 ohm.
Yeah. 2 plus 3 plus 1, 6 by 12. Inverse will be 2. Yeah. 2 ohms. What is the current that will be flowing through the 2 ohm?
It's 15 ampere.
Yeah, it's 15 ampere. So what is the voltage across A and B? What is the voltage across A and B? Current I
30
know.
volts.
Yeah, 30 volts. V is equal to I. Yeah. So between this point and this point, there is 30 volts. Now what they have asked? The power absorbed by the 6 ohm. Power is nothing but V square by R. V I know 30 square. R is nothing but 6. Now, is it simple now? Is it simple now? Now can you try solving it? Yes, Sonali?
Ma'am, how do we take the node here?
Yeah. See, in this circuit, these are all the same point, right? These are the short points. Like, these are the same point which has been given like this. Actually, we would have seen one question like this. A, B, whereas they would have given many resistors like this. Now, what is the equivalent resistance between A and B? For this circuit, tell me what is the equivalent resistance between A and B?
0.
0, because A and B are the same node, right? That's
Yes,
how,
ma'am.
like, you can, okay, to identify the nodes, what you can do is you can just take any one point as B and see whatever the points that are connected, take that also B. This point is B, then this point is B, this point is B. This B, I can't put here B because there are components in between. So I'll take another one letter A. This one is directly connected to A, so this is also A. Then naming the nodes are finished. Like what I'm saying is, first I'm taking this as A. There is a component here, so this is not A. I will take another one A. Here, this is the same line, so B. There is a component here, so this is C. Also, if I see this is a short, so this is the same thing, so C. And this is the same thing, C. Now C and A are not equal because there are components in between. So A, B, C. There are 3 nodes here. Is it clear now?
Yes, ma'am.
Okay. Now try finding the power and tell me the value. What is the power absorbed by the 6 ohm resistor?
It's 150 watt.
Yeah, it's 150 watt. What is the power absorbed by the 4 ohm resistor?
225 watt.
Yeah, it's 225 watt. What is the power absorbed by the 12 ohm
75
resistor?
75.
Yes. What is the power delivered by the 7 ampere current source?
It will be 210.
Yeah, it's positive, right? Only when the question they have
Yes,
asked observed, you will write it as
it will
minus
be
210.
minus
Yes.
210. Yes, ma'am.
Yes. Then the power delivered by the 8 ampere current source?
240 watt.
Yeah, 240 watts. Do anyone have any doubt in this type of question?
No, ma'am.
Yes. Please. Please clear your doubts in these type of questions. This is also some important. Yeah, please ask a question.
Ma'am, please take the question relatable with this, but with a ground node.
Okay. You want similar type of question, but you want here you can consider B as a ground, no?
Yes, but in a like a, I face so many questions in an exam that there is a ground node, and I don't understand how can I solve that.
Okay, yeah. I will try framing one question by myself. Hmm, I don't know whether the circuit is right or not, but just for the understanding, I will write this. Okay? Yeah.
Yes, ma'am.
5 volt, 2 ohm, 1 ohm, 1 ohm, 2 amperes. Okay?
Yes.
Hmm, okay. Now we have to find, otherwise, this will take time for solving. I'll take 2 voltage source. 3 volts. Now tell me what is the voltage across the 2 ohm?
2 volt.
Yes, 2 volts. Hmm. This is a voltage across the 1 ohm.
3.
3 volts.
No, no. There are two 1 ohms, right?
Yes.
Yes, ma'am. 1.5.
Yes, 1.5, 1.5. Yeah. So this is the positive terminal, negative terminal, positive terminal, negative terminal. I will give the symbol for resistor plus minus, and plus minus. If there is a resistor, plus and minus. The current is flowing in this direction. Current is here also flowing this direction, this direction. Okay, I'll draw it again, marking only the current direction. Current is flowing in this direction, and this direction. Okay, yeah. This is 2 ohm, 1 ohm, 1 ohm, 3 volt, 5 volt. There is a resistor R, and current is flowing towards the positive terminal of the resistor. Power is equal to,
V square by R.
yeah, okay. Tell me in terms of current and voltage. Uh, just tell whether it is plus I or plus V or minus V.
Minus.
How is it minus V? It's plus V and plus I. See, the voltage across this resistor is plus 5 volts and the current is entering the positive terminal. So it is plus V and plus I. Suppose if there is a current source whose voltage I am giving is plus V, current as I. What is the power absorbed here? This all power I am talking about is the P absorbed power. From the positive terminal, it is moving out. So I will take the IS minus I and VS plus V. Okay. So the power absorbed is basically negative minus VI, whereas in terms of resistor, it is positive VI. When it is
The
positive, it means
power
power is
absorbed.
absorbed. If it is negative, it is delivered.
The
Delivered.
So, ma'am, if the I
That's
is,
why,
excuse me, ma'am.
yeah.
I mean, if the I is
If I
exiting
is,
from the negative terminal, then power is
uh,
absorbed.
yeah, if the current is in this direction, if there is a current source like this, 2 ampere something, but due to some components here, the current is actually flowing in this direction, plus V minus V. Okay, then the power is equal to plus I, this I will take it as I, this I will take it as I naught, plus I plus V. Okay, Vi. This means this current source is now absorbing power. That means it is in charging mode. That's
Okay.
why to understand this, you need to know the Vi characteristics.
Like I mean, the first and the
V,
second, first and the third one.
if a
Uh,
resistor, it will be like this, no? Here V is also positive, I is also positive. Here V is
Yes.
negative and I is negative. So Vi is always positive. So resistor will always absorb power, right? Whereas if you
Yes,
take a
ma'am.
current source, how will you draw the graph for current source?
It will be
Will
parallel to
it?
the voltage source.
Yes. So in this it is positive, whereas here it is negative volt and positive current. In this area, it is absorbing power. In this area, it is delivering power. That means the current source can be used to deliver power and absorb power. This absorbing means we are charging, no, charging the battery. That we can charging the battery is like example for voltage source. So similar to that current source, it is absorbing area. In the same way, if you are having a voltage source, it will be like this. Here it is absorbing power. Here it is delivering power. This is example for voltage source, and this is example for battery. Is it clear?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
even though
yes.
even though voltage source and current source are used as a like used for observing or delivering power, they are most commonly used for delivering power. That's why we name it as active devices. So don't get confused with it. What are the active devices? Current source,
Voltage source.
voltage
Voltage source.
source, and there is another one active device. What is that? From this week 1 to 12, you would have seen another one active device, that is amplifiers, right?
Yes, ma'am.
Yeah. So passive devices are nothing but are resistor, inductor, and capacitor. Then, is resistor, capacitor, and inductor linear circuits or not? Are they linear elements or not?
Yes, ma'am.
Yeah, they all are linear, right?
Yes, ma'am.
Yes, ma'am.
Yes, they all are linear. What is an affine network?
Where the resistance, inductance, and capacitor are not like linear.
The difference between linear and affine network is if it is linear, its equation is y is equal to mx. If it is an affine network, y is equal to mx plus c. Linear network has to satisfy the condition that the line has to travel through the origin, whereas for affine network, it need not have to travel through the origin. So this is the difference between the linear and the affine network. For linear network, the line has to pass through origin. Whereas for affine network, it need not pass through the origin. It should be a straight line, but it need not pass through the origin. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yeah.
Ma'am, I have a doubt.
Yes.
Like in a summary session, you said that amplifier is not generating R power, it's just transferring power. So it is
Yes.
yes, ma'am. And now you are saying that it is a active element.
Yes.
Ma'am.
Yeah. See, if you see an amplifier, this is how an amplifier is, right? V is the input, A is the gain, my output is equal to A into V in. There is one V plus and there is one V minus. So there are two ways how we can see signal. In signal point of view, another one is energy or power point of view, right? In signal point of view, if you see, my input is a like signal of a millivolt range, and my output is a signal with a very large voltage because of the gain. If I take the gain is equal to 10, if it is 2 millivolt, it will become 20 millivolt here. So in my signal point of view, it is amplifying signal. Whereas in energy point of view, E out is E out. There is some energy here, E out, and there is some energy here, E in. And there is some energy due to this DC supply. This E out will be greater than E in, that is for sure. But we know, right, energy cannot be created in the process. Rather, here the energy is delivered by E in plus EDC. This active devices we are saying, that is in signal point of view, we are telling that that device is an active device. Whereas in energy point of view, you can see that this E input plus this EDC, then there is some losses due to the circuitry elements, energy losses, and the output will be basically less than E in plus EDC. So from energy point of view, the energy is not higher, the output energy is not higher than the input and the DC. Whereas in the signal point of view, we will consider only the two signals. So it is actually amplifying the signal. So we will actually consider the amplifiers as an active device. Okay. We are telling it is an active device by seeing based on the signal point of view. Is it clear?
Yes, ma'am.
Professor,
If we see as an
what is
energy point of view, then it is a passive element.
Yes. But usually we will be saying amplifier as an active device only, because see, it is actually amplifying some 2 millivolts to 10 millivolts like that. So we usually say it as an active device. But this energy point of view is to make you understand that the energy is conserved here also. Yes, Noel, do you have
Professor,
any doubt?
what is EDC?
Yes. EEDC. Where it is? EDC?
Yes.
Oh, EDC is like to make the amplifier work, there is a supply voltage, right? V plus and V minus. That is actually a DC voltage. So that is what we name it as EDC.
Okay, I got it. Thank you.
Yeah. So yeah, shall we? Okay. Did we start here? Okay, I was going to explain with terms of ground. Yeah. Yeah. Okay. Where did I get lost actually? Yeah. So yeah, I was telling here, no? Yeah. So yeah, now if you see, the current is actually entering the 2 ohm resistor. That also is solved, right? Where is the 2 ohm? It's actually 2 volts here. Here it is 1.5 volt and here it is 1.5 volt. What is the current here? Current flowing through the 2 ohm resistor?
Ma'am, 1 ampere.
Yeah, it's 1 ampere. See, the voltage 2 volt is across this plus minus, and 1 ampere is flowing into the 2 ohm, into the positive side. So the power is it positive or negative?
It is positive.
Yes, positive. 2 volts into 1
2
ampere,
volts.
right? So it is 2 watts plus
2
2
watts.
watts. Yeah. This is for this resistor. Now, come to this resistor.
Ma'am, but my question is how we got 3 volts here in this loop?
3 volts. This voltage source I have given the value, no? 3 volts.
In a previous
Are you
loop,
asking how?
we got 2 volts because there is a voltage difference. And 5 volts and 3 volts. So we got 2 volts.
Yeah. Yeah, here you got 2 volts. This 1.5, how you got is, see, here it is 3 volts, here it is 1
Yes.
ohm, and here it is 1 ohm. use the
Yes.
voltage divider formula, no? The voltage across drop across this is 1 by 1 plus 1 into 3.
Okay.
So
So,
it's
ma'am,
basically 3
we
by
had
2.
to consider 3 volts at that node
Yeah,
in
at
this
this
loop.
node it is 3 volts. Here it is 0.
Okay.
And you can also see that 1 ohm is the same resistor. So there will be equal voltage drop across the two resistors. So 1.45 volts here and 1.5 volts here. See, whenever
Yeah.
there is a ground, either connect the ground and make it assume it as 0 volts, right? Because
Yes.
whatever circuit you have, there is actually a 0 volts there. Even in this circuit which I have given here, here also, if you see this P, you can take it as 0 volts.
Yes. Because this is the ground.
Yes. If you see this current will be flowing like this. Current source will provide the current to the node, and from the node, because of the resistor, it will be dissipated, right?
Yes.
Okay. Then we'll go to the next question.
And please take a one question on find unknown resistance in the circuits.
Okay. Okay. That at the end we will see, okay?
Okay, ma'am.
Because, yeah. Yeah. So now we will be seeing just a fill in the blanks type of questions. Like these are very easy only, but just to revise and brush up the concepts. So yeah, the time period of a sine wave of frequency 50 kilohertz is dash microseconds. They are given frequency is equal to 50 kilohertz. What is the time period? What is the formula?
F is equal to 1 upon T.
1 by T.
Yeah, 1 by F. 1 by 50k, which is nothing but
200 microseconds.
hmm. Then the sampling rate they are given 40,000 hertz. Then they are asking us to find the time interval. What is the formula? It's again 1 by Fs, right?
Yes, ma'am.
Yes, ma'am.
What is the answer?
It's 25 microseconds.
25 microseconds.
Yes. Now they are given 10 cos 100 t. What is 100 here?
It's omega.
Omega. And what is the frequency of the signal?
Uh,
Please see the unit of the frequency before answering. They are given radian per second. What is the answer? Radian per second is angular frequency, right? Omega is also angular frequency, right? So the angular
Yes,
frequency
ma'am.
here is 100.
100.
Yes. So yeah, whenever they ask the frequency, don't just consider it as the hertz frequency. Please look into the unit, whether it is hertz or radian per second, then answer these type of questions. Okay?
Yes, ma'am.
Yeah. Now the next one, they are given the volt, 12 volt. Time they are given 10 minutes, so 10 into 60 seconds. Then energy they are given 21.6 kilojoule. Find the current. Yeah, find and tell me the answer.
3 ampere.
Yeah, 3 ampere. And also in this question, is it 200 microseconds? Are you
No,
sure?
ma'am, 20 microseconds.
20
Yes, 20
microseconds.
microseconds.
Ma'am, microseconds is 10 to power of 6.
Yes.
Yes.
So you will actually get 2 into 10 to the power minus 5. So it's basically 20 into 10 to the power minus 6. Yeah. So yeah, what is the formula? Energy is equal to
VI.
VIT, right? I is equal to
Ma'am,
EV by T.
can you
Yes?
please revise the formula like sample time is equal to frequency of sample, like something formula? I didn't remember that.
Yeah. One second. First question what they have asked is the time period. Okay. What is time period of a sine wave? Time period is nothing but the time taken to complete one cycle,
6 to
right?
5.
That is time period. But frequency. Frequency. What is frequency? The number of cycles completed in 1 second. That is frequency. So basically, 50,000 cycles is completed in 1 second. Then one cycle, I want to, let me take it as x second. So this is the time period. Time period is nothing but the time taken to complete one cycle. Frequency is nothing but the number of cycles completed in 1 second. So to find it, t is equal to 1 divided by 50,000 into x into 1, which is nothing but 20 microsecond. Okay? Is first question clear?
Yes, ma'am.
Yeah. Now the second question. They are given sampling rate. Oh, okay. Again, I will take the same sine wave as an example. What they are saying is, I am breaking this sine wave into points to discretize it. And sampling rate is nothing but the number of samples per second. That is nothing but sampling rate. So they are in the same way they are telling 40,000 samples. I am taking 40,000 samples from the sine wave in 1 second. Then what is the duration between two samples? Then for one sample, what is the duration? That means see, this is the same concept, right? See, in 1 second, if I'm taking this much samples, within one sample to next sample, what is the time duration? I will just again do the same thing. This x is equal to 1 by 40,000 into 1 second. So x is nothing but 25 microsecond. Now is it clear?
Yes, ma'am.
Yeah. Again, the third question is the sinusoid waveform is given by, okay. So if there is a sine wave, we know the equation, right? A sine omega naught t plus phi. This is the equation of the sine wave. Let it be v of t. A is the amplitude, right? Omega naught. Omega naught is the angular frequency. And phi is nothing but the phase.
Yes.
Angular frequency is nothing but angular displacement by time. You know this formula, right? Angular frequency is nothing but angular velocity. Angular velocity is equal to angular displacement by time. And also omega naught is equal to 2 pi f, because we will write the equation like this also, no? A sine 2 pi f t plus phi, right? So this is actually omega naught. So omega naught is equal to 2 pi into f. Now f is nothing but 1 by t. So omega naught is equal to 2 pi by t. So these are the three formulas which you have to remember in this. Okay?
Ma'am, in third question, it's asking for frequency, not angular frequency.
Yeah, but You have to see the unit, no? Even though it's angular frequency, they will just say it as frequency also. But you have to look carefully the unit. Only for the angular frequency, the unit is radian per second. If the unit they are given it in hertz, then you can go for F. Is it clear? That's why you have to look into the unit before answering the question. Then, is this question clear?
Yes, ma'am, clear.
Yes, ma'am.
Okay. Then the next question is, they have asked us to find the energy. P, we know it's Vi or V square by R or I square R. These are the equations we know for P. Whereas power with respect to time is nothing but energy. Or the work done over a period of time is the power. Oh, no. It's PT actually. P is equal to E by T. Work done over a period of time is the power. So it's VIT. So the formula for energy is VIT. Substitute the value of E, V, and T, you will get the value for I. Now is it clear, this question?
Yes, ma'am.
Okay. Now come to the next question. If the second harmonic frequency is 20 kHz, then the fundamental frequency is dash hertz.
Yeah.
Fundamental frequency is equal to 10 kHz. Anyway, we will just revise the concepts of harmonics also, since it's a small topic. Yeah. See, again, there are 2 points in the wall and a string is attached, and it is with, so it is L, and this wavelength is nothing but lambda by 2, because only a full oscillation will take it as lambda. Here only the off oscillation is there, so L is equal to lambda by 2. Lambda is equal to 2L. Again, now the waveform is changing like this. Here it is lambda L 0. Here lambda is equal to L. What is the lambda here? What is the L value here? L is equal to, this is lambda by 2, lambda by 2, lambda by 2. So 3 lambda by 2. Now, this one is the fundamental frequency. This one is the second harmonics. This one is the third harmonics, right? Now, frequency into lambda is equal to, what is the formula? Mu into lambda. Do you remember this formula?
Yes, ma'am.
Yes, ma'am.
Yeah. Frequency into lambda is equal to speed of light, right? The speed is constant, so I'll take fundamental frequency as F1, and lambda is nothing but 2L is equal to F2L is equal to F3, 3 lambda by 2. That is nothing but 2L by 3. L cancel. This I write it as 2 by 2, 1. So F1 by 1 is equal to F2 by 2 is equal to F3 by 3. This equation I will take. F2 is equal to 2F1. F3 is equal to 3F1. That means F1 is equal to N into, this is the fundamental frequency. Right? So that's the formula we have applied here. Second harmonics is equal to N into fundamental frequency. They asked us to find the fundamental frequency. So 20 kHz divided by 2 is equal to fundamental frequency equal to 10 kHz. Is this clear?
Professor,
Yes.
Professor, in the assignments, these kind of questions normally presented by a graph with indicated second harmonic frequency and the first harmonic frequency. So I don't know, this second harmonic frequency is like it's like a theorem, right? It the um
No, I'm not able to understand.
I mean, when I did assignments, normally the question will be presented with a graph with all the like
Yeah, two or
led
three
to.
sine waves overlapped like that, right?
Yeah, but in this question, there's no graph to indicate what is
Yeah,
second harmonic frequency.
but the question as it has been given, no, the second harmonic frequency is 20 kHz. That data is enough for me to write the answer, no?
So it's like a theorem, right?
Yeah, like so. Actually, this question I framed it. So basically, what I meant is for a given like in a given like waveforms, if the waveform second harmonic frequency is 20 kHz, what is its fundamental frequency? Okay, maybe I'll change for a given waveform. If it's second okay, if it's second, okay, now it's clear, right? Noel?
So if I've given this kind of question, I just use this the numbers you gave, right?
Yeah, the date number is enough. So basically, the graph you are saying that they wouldn't have given the frequency explicitly. From the graph, you would be required to find the frequency. Then from that, you have to find the second harmonics or whatever you want. But here, instead of giving the graph, I directly gave you the value. That's the difference.
Okay.
Yeah. So the next question is, so there is a waveform, whatever can be the waveform. It is sampled as 10 kilohertz. That means 10K samples for 1 second. For 5 seconds, how many samples? What is the number of samples happening for the duration of 5 seconds?
50.
Yeah. So x is nothing but 5 by 1 into 10K, right? It's equal to 50K samples. So basically this arrow I'm writing, no? So yeah, I will just explain to you. See, yeah, if I'm telling 10K samples, I'm getting for 1 second. I'm telling you x samples I'll get for 1.5 seconds or 5 seconds, whatever it is. So see, if you're going, this is, we call it as ratio method normally. If these are directly proportional, I will just write like this and divide it. So 10K by x is equal to 1 by 5. X will go here and 5 will go here. X is equal to 50K. This we can't use everywhere, only where the both the sides are directly proportional. Okay. Otherwise, you can go by using the formula itself. Find in one for transmitting in 1 second if it is 10K samples, in 5 seconds, then 5 into 10K samples. Like that also you can calculate. Yeah. Shall we move to the next question?
Yes, ma'am.
Yeah. So consider the frequency context in a signal 2 pi f1t plus phi 1 plus b sine 2 pi f2. Like basically the message signal they are given, then the carrier signal also they are given. They have asked us to find the lowest frequency and the highest frequency in the modulated signal. Yeah. Try solving it, then we'll solve this together. So basically this is 10 megahertz frequency. Here this I'll take it as FC. F1 is equal to 100 kHz. F2 is equal to 500 kHz. So all the possible combination of the signal is FC plus or minus F1, FC plus or minus F2. So you will get 4 frequency values. Write the 4 frequency values. Out of it, the lowest will come here and the highest will come here. This is how we solve this type of questions, right?
Yes, ma'am.
Yeah. Try solving and tell me the answer. So that is a carrier signal. Then there are two frequency components, F1 and F2, and each are represented by different frequencies. Yeah, by law, we need a carrier frequency which has to be much more higher in frequency than my message signal. So these two frequency components will get uh, embedded in the carrier signal.
Ma'am, the highest is like 510.
5. No. Can you please repeat the answer?
No,
10,
510.
10 in megahertz, no? No.
The
See,
lowest
it's
one
10
will be
m.
9.5 megahertz and the highest one will be 10.5.
Yes. Is this the same answer you said, Gaurav?
Ma'am, you wrote the answer in the base of
Zero.
Okay, okay.
lowest frequency. Yes, ma'am.
Yeah,
That will be
10.5. Yeah,
9.5 and this will be 10.5 frequency.
yeah. The carrier signal is 10 m. So one will be plus or minus 100 k. Another one combination will be 10 m plus or minus 500 k. So basically, this combination will give the highest and the lowest value, right? So plus will come to highest and minus will go to the lowest. Yeah, did everyone get the answer?
Yes, ma'am.
Then we'll go to the next question. So there are 10 devices, 4 bit, frequency of 100 kHz. What is the total time? Yeah, both are same question with different, little different. So tell me the time for both. What is the answer for seventh question?
For the first one, is it 40 microseconds?
Yes, it's 40 microsecond. So yeah, what they are given, there are 10 numbers.
And for the eighth one, it
And
will be 400 microseconds.
yes. So in the seventh question, what they said is there are 10 pair, each are having a dedicated wires. So basically one wire and one ground. Each transmitter want to transmit a message of 4 bit with a frequency of 100 kHz. So time duration to send 1 bit is 1 by 100 kHz, which is nothing but what is the value? It
It
will
will
be
be
around
10
10 microseconds,
microseconds.
I think.
Yes, ma'am.
Yeah. Then 4 into 10 microsecond. So basically, in this question, what they're saying is all the 10 devices are transmitting the 4 bit at the same time, but 4 bit is sending one by one. So 4 into 10, but all the 10 are doing at the same time, no? So we don't have to add the time.
Yes,
Whereas
ma'am.
here,
Here
they
it's
are given, right?
transmitting parallelly.
Yeah. Yes. Whereas here, it is each 10 devices is transmitting one by one. So all the time will get added up. So 40 into 10, so 400 microseconds. Do anyone have any doubt in the seventh and eighth question?
No one.
Excuse me, ma'am. I think the same question which I asked, the seventh one which I asked in the previous class. So there
Yes.
you said that for For 4 bit, we have to consider 1. Means for 4 wire, we have to consider it as 1 bit for each.
Okay, 1 second. Give me a minute. Yeah, actually, I taught you this in the last class. That's why I added it here. Give me a minute. Yeah, now tell me, Sonali, what is your doubt? Hello?
Yes, ma'am. So
Yeah, Sonali.
there you said me that t is equals to 10 microvolt second.
Yes.
The here is the 4 bit, so each are connected with the parallel. So each wire having the one bit.
Yeah, because see, in that question is this one, right? That is a practice assignment question, whereas this is a graded assignment question where they given 4 independent wires for each pair. So that's the reason why I took it at like that. Right? Actually, this is a different question. I took it from a graded assignment. So yeah. Also, like, yeah. Can you please ask your doubt again?
A dedicated wire means if it's connected in a parallel.
Mm. See, here they are given for 10 numbers of transmitter receiver pairs. For that, it is connected through a dedicated wire. That means 1, 2, 3, I will take. Each are connected through a dedicated wire. Then each transmitter wants to transmit a 4-bit data and at a frequency of 100 kHz. Right? In that question, we will see. Suppose there are 4 devices, each equipped with a transmitter receiver pair, all connected through a dedicated wire medium. Each transmitter wants to transmit a message. Okay, 1 second. 4th, 5th, 6th, right? Yeah. So this is a question we discussed that day. Each transmitter wants to transmit a message of 4-bit data if the transmission occurs in parallel through 4 independent wires, one for each transmitter receiver pair. Mm. Mm. Okay, here they have multiplied this 4-bit into 1 by 100K, right? Or
Yes, ma'am.
no?
And the answer should be here also the 40 microsecond.
Yeah, right. Yeah. Okay, I'll check this question and tell you. Okay, this 4 independent wires is like for this transmitter receiver pair. Okay, I don't know how for what they mentioned this is 4 independent wire for the 4 bits or the 4 devices. Because okay. If you see here in the question, they are given 10 devices connected through dedicated wire medium. So one for each. Then each transmitter wants to transmit a data 4-bit data at a frequency of 100 kHz. Okay. But if you see that type of question, you can see for the 4 devices, they have already connected a dedicated wire medium. 4. So already it has been connected. Each transmitter wants to transmit a message of 4-bit data. So yeah, each want to transmit 4-bit data. If the transmission occurs in parallel through 4 independent wires. So yeah, this so there is a doubt whether this 4 independent wires is for the 4 devices or the 4 bit, right? Am I clear? Like, am I right? I am going in the right track, right? Sonali, are you there?
It's already written there. It's 4-bit data.
Yeah, 4-bit data. Okay, yeah. Actually, in this question, this 4 independent wires, they are given for transmitter receiver pair. Yes. They didn't mention it for the 4-bit data, right? This is a doubt, right?
Yes, ma'am.
Yeah, yeah. Actually, in the question, it should have been like 4 independent wires for the each bit data. Then only the given answer will be right. 10 microseconds. But here the question is little bit changed. Okay, this 4th question, no, I will like check and tell you because it is little bit confusing. I don't know whether this 4 independent wires is for the transmitter receiver pair or for the 4-bit data for which they are mentioned. But the answer they have given it as 10 microseconds. So yeah, basically this type of questions, there will be like one transmitter receiver, transmitter receiver, transmitter receiver, transmitter receiver. There are 4 possibilities for asking this type of questions, right? So here I'll take 4 bits. Frequency time duration to send, I will take it as 1 second. Then 2 devices. It can either happen like first this device is transmitting 1 bit first, then second it is transmitting the next bit, next the second device start 1 bit, then so it is happening sequentially. First this one, then this one, then this one, then this one, 1 bit. So what is the time duration here?
4 seconds.
No, take it as 4 bits, no? Everywhere take it as 4 bit. So 1 by 1 bit sending for first device, then 1 bit for the next device. So what is the time taken? For each bit transmission, it is taking 1 second.
4 seconds.
Is it 4 seconds? First, I'm completing the device 1, then only I'm going to the second device. It's happening sequentially.
8
First
seconds.
1 is over.
8 seconds.
Yes, it's 8 seconds. It is because 4 into 2 into 1. First, my first device, 1 bit is transmitted, next bit is transmitted, third bit is transmitted, fourth bit is transmitted. So here it's taking 4 seconds. After the completion of first device only, my second device is starting. So again 1 bit, next bit, next bit, next bit. So for here it will take 4 seconds. So totally it will take 8 seconds. So this is one case. There is another one case.
But
1 bit is transmitted. 2 are happening parallelly, but it is sending 1 by 1. So what is the time taking? 2 are happening parallelly, but each bits are going 1 by 1. Now what is the time? Consider what I'm
It's
saying.
32.
No? See. No, right? See, this first transmitter receiver, it is taking sending 1 bit first. So it is 1 second at first. Then second bit, so another 1 second. Third bit, then another 1 second. Fourth bit, another 1 second. It is happening at the same time with the next one. So the total time is 4 seconds, right?
Yes, ma'am.
Yeah. Now I will go to the. Yes.
But I mean, how can I indicate, like what kind of case? I mean, how can
Yeah,
I
it's
find
at.
indicate in the question?
Yeah, it will be actually given clear in the question. Maybe in practice assignments, one or two are confusing, but mostly in the graded assignment, all are given clearly. But in practice assignment, that fourth question, like I am not very sure. I think only that one is confusing. Other than that, all are like clear and good. So basically, there
Madam,
are
can
only
you
four
show,
cases.
madam,
Yeah,
can you
yeah,
show
yeah.
me the question? Show me the question again.
Which question? Practice assignment or that the question we discussed today?
There are 10 transmitters separate.
This one, this one.
Ma'am, why not you divided by 10 because there are 10 separate transmitters are transmitting the data simultaneously?
Yeah, but see here, they said there are 10 devices going on like this, okay? Each are connected through a dedicated wire medium. Connect it like this. Then each transmitter wants to transmit a message of 4-bit data. Each transmitting 4-bit. Each transmitting 4-bit. So if you consider one device, it is transmitting 4-bit data through a single wire at a frequency of 100 kHz. 1 by 100 K is nothing but 10 microseconds. So the time taken to transmit one bit is 10 microsecond. For one device to connect it through one wire, it has to send 4 bits. So 4 into 10 microseconds. So it is 40 microseconds for one device. And all these 10 devices are happening parallelly. So it is independent of each other. It is not depending on the previous one. So all are happening at the same time. So the total time is 40 microseconds.
Okay,
So
ma'am.
here the answer is 40. Yes. Whereas in the second case, if you see, there are 10 devices. Here it is happening one by one. After the completion of the first one, only second one is starting and completing. Then third one and starting and completing. So it is adding 40. Then again this will complete and give 40. It is continuing. We have to add it for 10 times. That's why we are multiplying into 10. 40 into 10. 400 microseconds. Is the 7th and 8th question clear to everyone?
Okay, so Professor, if the question is indicating that devices transmit signal one by one, which means that's the second
Yes.
case. You
Yeah.
okay?
So basically, these type of questions they'll be playing with the words. So be careful with it. So yeah, it will be either like the transmitter and receiver will be sending data serially or parallelly. Otherwise, the 4-bit, whether it is transmitted serially or parallelly. So this will be happening into 2 into 2 combinations. Okay.
Okay, ma'am.
Okay.
So, ma'am, if it is transmitting the
Uh,
data one by one, then we will consider the device. Otherwise, we will not consider the device, right?
yes. Yes. If the device is like if first device is transmitting, then it is over. Then the second device has started transmitting. Then that is also completed. Then the third device. Then this is we call it a serially happening. No. Then we will multiply
Yes,
into
ma'am.
that device number. Yes.
Okay, ma'am.
If all the devices are transmitting at the same time, we will not consider because it will be the same time. The same
So,
concept for the
Professor,
bit also. Yes.
so the
Yes,
third
Mahi.
and the fourth case you've been talking about, that's 4 cases, but the third and fourth
Yes.
case is like serial connected like cases, right?
Yes. So here what I meant to say is like all the bit will be transmitted at the same time. I will complete this one. Here, but see, here both the transmitter and receiver are doing at the same time. All the 4-bit are happening at the same time. Then what is the time taken?
1.
1 second. Yes, right. Here, all the 4 bits are transmitted at the same time using 4 different wires. Whereas the first device will complete, then the second device will start. Now, what is the time period?
2 seconds.
2.
Yeah, 2 seconds. So yeah, only in these four combinations they will ask. So be clear with the four combinations, then you will be able to answer any type of questions. It's clear, right? Do anyone have any doubt in this
Ma'am,
transmission type of question?
we
ma'am, can you
having
explain
we
Yes.
have
the 2 second one?
Yeah. First, Gauran should tell me once again what happened.
Ma'am, can you explain the fourth part again?
Yeah, yeah. Then Sonal, you were telling something. What was that?
ma'am in third and fourth we have a 1 bit or four bit.
4 bits, but four are happening at the same time. So it will take the same amount of time. Yeah, wait. I will draw the diagram clearly. This time you try telling the answer. Transmitter, receiver. So first 1 bit is happening. First this is sending. Then after first one finishes, the second one is starting transmitting. So in this case, device 1 first transmitted, then device 2 is transmitting. After the completion of device 1 only, the device 2 is starting to transmit. In bitwise level also, first it is sending 1 bit data. Uh, okay, basically instead of indicating like this, I can use only 2 wires to show, right? It will be easier. So it is having only 1 wire, serial communication, but it is transmitting 4 bit. Here also it is having only 1 wire to transmit the 4 bit. So now tell me what is the time taken for this type of transmission?
4 seconds.
8 seconds.
It will
8
be 8
seconds, right?
seconds.
I'm
Oh,
telling this after device 1 is sending first. Then after that device 2 is sending. Then I have to multiply the number of devices, then 4 bit into the 1 second transmission time, then t seconds. Now I'm taking again the same single wire to transmit all the 4 bits. There are 2 devices. Here I'm saying both the transmission happen at the same time, parallelly. Now what is the time?
Then one
It will be
second.
4 seconds.
4 seconds, because here it is 4 bit, here also it is 4 bit, so 4 into 1 second. Is it clear?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yeah. Now the third case is there is a transmitter, receiver. Each transmitter has got 4 wires for 4 bit. This transmitter has also got 4 wire, and both are happening parallelly. What is the time?
1 second.
1
1
second.
second.
Yes,
1 second.
1 second. Then
Ma'am,
again, yes,
now in the third case, it is 1 second because like for each wire is
all
transferring 1 bit continuously.
1 bit. Yes, all happening at the same time.
Yes, ma'am.
So there are 4 wires here, but serial communication. Like first the device 1 is getting completed, then only device 2 is starting. Now tell me what is the time?
2 seconds.
Yeah, 2 seconds. So yeah, I hope now you are very clear with these concepts. So yeah, read the question very carefully. They will be playing with the words, but yeah, at the end of the question, the concept is this one only. So yeah, so we are covered from the previous session and today's session. Okay, maybe yeah, we have already crossed 8 o'clock. If you guys have any other work you can do, or do you want me to revise from week 1 to week 12 a few important concepts? Like if you're okay with that, then I can go through it.
Madam,
It will
in
be
this
like a
session, I have a doubt in one question.
yeah. From is it from activity question like that, or from the question which we discussed today?
Discussed today. Man, call up.
Yeah, yeah. Tell me.
I,
Uh, in the problems, right?
there was a question which did, uh, we have to determine the power delivery of the current.
Yes, yes.
That
Power
question.
delivered by the 7 ampere. Yes.
Hmm. This question.
Yes. This one, right?
Hmm.
Yeah, what's the doubt?
How did you calculate that power delivered by the current source?
Yeah, 7 into the voltage 30, right? So it is
Hmm.
210 watts. We have found
Okay.
the
Okay.
but in the question, if they are asked absorbed, then we will write it as negative. But since they have asked delivered, we will write it as positive.
Mm-hmm.
Actually,
Understood.
ma'am, the same question like
Yes.
cannot we apply like P is equal to V square upon R?
You
So
can, but
7
see, there is no resistance for this current source, no? How will you be able to calculate like that? For current source, there are no resistors involved. Like if there is a resistor in series, then also it will be not possible, I think.
Okay, ma'am, got it.
Yeah. 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 Do anyone else have any doubt from any questions which we discussed today? And
No.
also tell me if you guys are okay with it, I'll go through from week 1 to week 12, but it is already time. If you don't want, then fine. Otherwise, we'll solve the question which I gave on one yesterday. Yeah, this question we'll solve and then we will end the session. Is it fine? Or do you guys want to revise?
Ma'am, we'll just solve this question.
Yeah, okay. Yeah. Now we are going to find the node voltage. Yeah, what is the method we can use here?
Ma'am, nodal analysis.
Yeah, we can use nodal
Hmm.
analysis or mesh
Yes,
analysis,
ma'am.
whatever.
Mention.
Hmm. We know I1 is equal to 1 ampere, I2 is equal to minus 5 ampere. So 1 I3 plus 1 I3 minus I2 plus 1 I3 minus I1 equal to 0. So my I3 will be no, actually we can use nodal analysis here because we have to find node voltage V1, right? So anyway, we'll complete and go. Plus I3 minus plus 5 plus I3 minus 1 equal to 0. 3 I3 is plus 4 equal to 0. I3 is equal to
4 by 7 minus 4 by 7.
actually that is also not needed. What is the current through the 4 ohm? It's I1 plus I2. Yeah, right? At this point, if you apply KVL, see, here it is 1 ampere, here it is 5 ampere. So at this point, it's actually 6 ampere. So
Yes, ma'am.
V1 is equal to IR is 6 into 4, 24 volts. Is it right?
Yes, ma'am.
Yeah. We can solve it like this also, no? Yeah. So yeah, basically finding the easiest way to solve any questions. V1 is nothing but the voltage drop across the 4 ohm. So V1 is equal to 24 volts. Yeah, do anyone have any doubt in this question?
No, ma'am.
Yeah. Okay, I will revise KCL, KVL.
Ma'am, can you
Okay.
please revise the formula of low pass filter and high pass filter, sine wave and square wave?
Okay, yeah. KCL, KVL, low pass filter, high pass filter. This both with step input and sine input. Okay,
Yes, ma'am.
this concept. So yeah, what does KCL say? Say okay. I'll give it with a question. There is a node Here it is 5 ampere, 2 ampere, 3 ampere. What is the current here?
4 ampere.
4 ampere.
5, 6, yeah, it's 4 ampere. Because according to KCL, at a node, current entering will be equal to current leaving, right?
Yes, ma'am.
So yeah, next we'll go through KVL. This is 5 volt, 2 volt, 3 volt, and this is 1 k ohm. How will we write the loop equation? 5
5
plus 3 minus 2 is equal to 1 ki, right? Is this equation right? Do you agree with me? Because according to KVL, potential increase will be equal to potential drop, right?
Yes, ma'am. It's correct. Yes.
Yes. So this is how we write the equation. Now, there is a step input I am giving. There is a resistance. There is a capacitance. My step input is u of t. Okay. At time is equal to 0, my input becomes Vm. This is R and C. So V in is equal to u of t. So what is my Vc of t formula?
Vm bracket 1 minus e to the power minus t upon RC.
T by RC. Yes. So this is when I give a step input. In the same way, if I am taking the value across the resistor, the same input I am giving, what is my VR of t?
V in minus Vc.
Yes, ma'am. It will be
Yes.
step input minus Vc.
Vc of t. So yeah, tell me what is the value?
Vn minus Vm into 1 minus e to the minus a minus c.
Vm, right? This Vm will get cancelled. So e power minus
Yes,
t by RC into Vm. Yeah. These two cases. So basically, this is a low pass filter and this is the high pass filter. Now we will look at the graph response, how it will be. Time with respect to Vc of t. This is my step input Vm. My VCAT of will be gradually increasing from 0 to like this. Right? Whereas this is Vc of t. Whereas Vr of t will be reducing like this. This is Vr of t. And this is the point at which they both intersect. What is this point?
0.693 RC.
Yeah, it's 0.693 RC. Yeah. Now, if I am giving a sine input, A sine omega t, R and C. What is Vc of t that I will get? What is the final formula? It is nothing but A by 1 plus omega naught square R square C square root of sine omega naught t plus pi. Okay. So actually this is a
Yes.
low pass filter. That means it will allow low frequency, cut off high frequency. Then what is phi here?
Phase.
It will
So
be
it's
tan
actually
inverse
minus. Yes, tan inverse of omega naught RC.
omega naught RC.
And what is the cutoff frequency formula? 1 by 2 pi RC.
If it
Then what is the angular frequency formula?
1 upon RC.
1 upon RC.
Yeah, 1 upon RC. Yes. Now, again, now I'm going for a high pass filter. This is a V in is equal to A sine omega naught t my capacitor is here, my resistor is in this side, and I'm taking the voltage across the resistor, VR of t. What is the value? It is nothing but A sine omega naught t minus A
Yes.
by root of 1 plus omega naught square r square c square sine omega naught t minus 5. Right?
Yes, ma'am.
The same will apply here also. If you are finding only the amplitude, then I will just find the amplitude. A minus A by root of 1 plus omega naught square r square c square. Right?
Yes, ma'am.
Yes,
Yeah.
ma'am.
Yeah. Any other doubts?
Please take one request, ma'am.
Yeah, please tell me again. Your voice is a little bit broke down. Yeah. Yeah, please. Someone was telling.
I will explain just like the switch-based capacitor questions.
Ma'am, one question on
Switch.
switched
Yeah,
capacitor.
unknown resistance. Any circuit.
Okay, one second. Someone was asking something, but I couldn't hear. Switch capacitor, I heard. Any other doubt? Mohit
Asking,
already tell you
uh,
something.
ma'am, he is asking about the finding the unknown resistance in a circuit.
Unknown
Yeah.
resistance.
Okay. Okay.
I mean, also tell like should the low pass filter should be higher than the high pass filter for band filter.
Yeah. Okay. Yeah. That frequency, right? Yeah.
Yes.
So this is the bandpass filter that I need. This is my low pass frequency. I'll cut this into two. This is the low pass filter, right? And this is the high pass filter. Do you agree with this?
Yes,
Just
ma'am.
cut this into two. This whatever in the right side is a low pass filter, and whatever in the high pass filter is the left side.
Yes, ma'am.
So here there will be a cutoff frequency for low pass filter, and here it will be a cutoff frequency for high pass filter. Now it's this with respect to frequency. Now you tell me, will omega L be greater than or less than omega H?
It will be greater.
Greater
It will
than.
Yes.
be greater than.
See, some people will represent this omega L as omega H also. They will write this point as omega H. That means omega H will be greater than omega L. They will take this as lower frequency and this one as a higher frequency.
Okay.
So yeah,
And like ma'am,
but in the question, yes,
like ma'am, to form the band pass filter, the
yeah,
low pass.
for to form the yeah,
Yes.
to form the band pass filter, the cutoff frequency of the low pass filter should be greater than the high pass filter.
Okay.
Because if you consider this case where my omega, I will take this omega L, it's omega L and omega H. If my omega L is less than omega H, this is for low pass filter and this is for high pass filter. So my graph will become like this: omega L, omega H. So this is not a band pass filter, whereas this is a notch filter, right?
Yes, ma'am.
Yeah. Now I will solve one question where we are supposed to find the resistance value. It was something like this, I think. $30 volts, 20 volts. So yeah, mm, there is some current coming here. I can take this as okay. I'll give some randomly 2 ohms or 3 ohms. If I say there is a current 1 ampere, Then here it is 2 ampere flowing. Yeah. Okay, actually this one itself is not needed. Yeah, now tell me how to find the unknown resistance here. With this true information, will I be able to find the voltage across this resistor?
Yes, ma'am.
Yes, ma'am.
It's 2
2
volts, right?
2 volts.
So across
Yes.
here, what will be the voltage?
28.
Yeah, it's 28 volts.
28.
Now across this 3 ohms, what is the voltage? Here it is 20, so here it should be 3 volts. It should be 8 volts, right?
Yes, ma'am.
Yes,
Okay,
ma'am.
wait, I'll draw again. R 1 ampere, 1 current I have given 30 volts, 2 ohms, 3 ohms, 20 volts. Yeah, we already found the voltage across here is 2 volt. Since we found the voltage across here, we know the voltage across here will be 28 volt. Here 28 volts, here 20 volts. So here it should be 8 volts. Now I know the resistance and the voltage here. From this I can find the current flowing. What is the current?
2 point something.
Yeah, 2.67.
V by
Now
R. Yes.
in, yeah, here I can apply KCL, right?
Yes, ma'am.
3.67.
Yes, ma'am.
Now I have the voltage value and current value. What is the resistor value? It's V by I, right?
V by I.
Sev-
Yes. 28 by
7.3.
3.67.
Okay, 28 divided by 3.67, right? Yes, yes. You'll get around 7.63 ohms. Now is it
Yes.
clear?
Yes, ma'am.
Yeah.
Yes, ma'am. Thank you.
Okay. Now regarding switched capacitor, wait, let me take a question. Otherwise, do you want me to explain some derivation from the week 12? Or do you want to solve the question? There are
Ma'am,
many derivations, right? If you have, yeah, please, Gauranj, can you please repeat again?
No, ma'am, not very. Actually, just solve one question on switched capacitor, which is in week 9.
Okay. Okay. From
ma'am,
week
for
9, okay, can you please put it in the chat box? Because I don't know whether my signal is little weak or not. Switch capacitor, yeah, now we will solve one question. Questions related to band pass filter. You will be asked to solve some like finding the frequency only. You will not get many complex type of question from band pass filter. That is not discussed in the lecture series also, no?
Okay, ma'am.
Ma'am, can you please solve the question number 10 from the 12th grade assignment? It's like based on switch case, like the switch capacitor.
Okay. Practice assignments or graded assignment?
Graded assignment, week 12.
Okay, graded assignment week 12. Question number?
10.
Okay, 1 second. Okay, this is the last question. This is the last question of that. Yeah. The switch has been open for a long time and is closed easy. It is open for a very long time. The voltage across the capacitor at T is equal to 1 second. Okay. Okay, actually I haven't tried solving this before. So yeah. But there are two voltage sources, right? Yeah. So initially, so the switch has been open for a long time and is closed at T is equal to 0. So we have to find for only this type 10 volt, 2 ohm, 1 by 3 farad. So Vc of T is equal to, and initial capacitance value they have not given. So I will take it as 0. Vc of 0 minus is equal to 0. Okay.
Ma'am, like, can't we
Not
take
here.
VC value
Here
as 5
V
volt?
initial is equal to 0. Yeah, can you please repeat again what happened?
Ma'am, asking like, can't we take VC of T as is equal to 5 volt? Like,
Why in the question they have not given no as 5 volt? Oh, you are saying like the voltage will be divided across 2 ohms and like that, huh?
um,
Oh no, you can't do that because the switch is open. The switch is open, so it's basically an open circuit there.
Ma'am, your voice is breaking.
If this circuit is open, yeah, 1 second. Now is my voice clear?
yes, ma'am.
Yeah. So yeah, if you see, okay. 10 volt, 2 ohm. So here it is open. It means even if the circuit is like this, the current will flow in this direction. In this direction, even if the current flows, here there is an open circuit. So the current will not flow across this branch. That's why we are not considering this part at all in the first case. Because see, they said the switch has been open for a long time. Now, even before time is equal to 0, we are calculating. We are not even considering. You have to read the question first. The switch has been open for a long time and is closed at T is equal to 0. So the changes will happen only after T is equal to 0. So before that, the circuit has been in this condition. So Vc of T is equal to 10 1 minus e power minus t
Now
by
your voice is
RC,
cracking or
but it has been open for a now. Okay, 1 second. Yeah. Okay. Now is my voice clear?
yes, ma'am. Now it's
Yeah.
clear.
Is my voice? Yeah. So yeah. See, if they are given, it has been open for a very long time. So I will take it as infinite time. So if it is a 10 volt, this resistance will determine how fast it is going to reach the 10 volts. So after a very long time, the voltage across the VCT will be equal to 10. Do you agree with this point?
Yes, ma'am.
Yeah. Then 1 by 3 farad, voltage is 10 volt. Then there is 6 ohm. Then there is the voltage source, 5 volt, right? Okay, the switch has been opened. The 1 second. Is my voice again breaking? Okay. Now the circuit has become this 5 volt. There is one capacitor, one resistor, but this capacitor is also having 10 volt by 3 farad. Then there is so. Now what will I do? I can write a current equation, right? I will write KCL. I phi is equal to I is equal to C dV by dt, right? Okay. The same current will be flowing through here and there also. So I'll take it as IC of t. This will be 0 volts. Okay, 5 volts. Okay, IC of t is equal to C dVc by dt. This is one formula I have. Then IC of t is equal to VR into by 6. There is this formula also, assuming voltage drop is VR here. Okay, I am not very sure how to solve this question because I haven't tried solving it before. Okay, maybe in the next session I will try solving this question. Is it fine?
Yes, ma'am. So, ma'am, like, if these types
Yeah.
of question like comes to us in the suppose in the exam, ma'am, what should be the basic approach to go through
Yeah,
sequence?
it's actually see you have to write the differential equation. That I'm sure. You have to write the differential equation, then integrate it and solve it. Even in the session, they would have taught one question like this. Wait, let me check that. There is one voltage source and capacitor, right? Yeah, there is one question.
Madam, can you solve the fifth question of this graded assignment?
Okay, it's actually 8:30, no? So yeah, we will solve. Okay, in the next session, I will ask your TA to solve the week 12 graded assignment also.
Okay, ma'am.
So on Wednesday session, we will solve this.
So, ma'am, we would be having two sessions after before the exam.
No. You will be having one more session where actually it is planned for mock discussion. But anyway, yeah, we will also solve this week 12 graded assignment also. maybe like not all graded assignment, maybe like which are at the like last few questions, because that will be more complicated than the questions at the beginning, no? So yeah, we will solve 2 or 3 questions at the last 2 or 3 questions. Is it fine?
Okay, ma'am. One more
Yeah,
doubt
ma'am,
is the exam
go
pattern
through.
of the ESTC. Because I heard about that we have written exam.
Okay, yeah. No written exam.
So how about
So the okay.
mm,
So you can expect questions like fill in the blanks, MCQs, then true or false. Okay, one second. Let me check and tell you the exact question
I
pattern.
mean, handwritten exam like that we have to submit week 11 and 12 the handwritten solution in the portal.
Better if you write and submit. But week 11 and week 12 is not included in the grading, right? Am I right?
Sorry, ma'am, your voice is breaking.
As per my knowledge, week 11. Yeah. As per my knowledge, week 11 and 12 is not included in the grading. Is this information correct? I'm not very sure. Maybe I'll confirm and tell you.
Okay, ma'am.
Is my voice still breaking?
Yes, ma'am.
Okay. Now is it clear?
Yes, ma'am. It is clear now.
Okay. Mm.
Ma'am, what are you telling about week 11, 12?
Okay. Wait 1 second. Actually, I don't. Okay. First, I was going to tell you about the pattern, right?
Yes, ma'am. Pattern, exam
So the
pattern.
pattern for NSEM is more or similar to quiz 1 and quiz 2. You will expect five. Sorry. Okay, 1 second. Yeah. 5 true or false. Then 10 MCQ. Then comprehension type of questions. Like
Comprehensive means?
comprehension is like you will be given one circuit, and from that you will be asked to find answers, like similar to this type of question which we saw today.
Oh, okay.
You can see, this power type of question. One diagram will be given, and from that diagram you will be asked to find 5 or 6 questions. So those are the comprehension type of questions. Then what else I was saying? I was telling something actually. Yeah. Then in the next class, you'll be having a mock discussion. Maybe I will ask your TA to discuss a few problems from your grade assignment of week 12 also. Then anything else?
So, ma'am, handwritten will not be considered in this exam.
From week 1 to 10, it will be considered. Only week 11 and 12, actually, it is not considered for grading, I think, week 11 and 12.
No, ma'am, I
Did
am
you read
telling about
the student
in-term
handbook?
exam. In-term exam.
Yeah. Mhm. Portion is from week 1 to 12.
Okay. So just
Portion is,
one doubt. The whole in-term exam will be CBT based. EDS?
yeah,
Okay.
like CBT based means like you are saying it as
Oh,
like
competent.
a portal, you have to write the solution, like only the numbers, like that, right?
Yes.
Yeah.
And PQ and numerical based.
Hmm.
Okay, thank you.
And could you please solve one
Yeah.
question from graded assignment week 9, question number 7?
1 second. Let me check the question. Week 9.
Ma'am, can you please upload the solutions? Like, for the.
Yeah, it will be uploaded by tomorrow or day after tomorrow.
And like, ma'am, can you please ask like where to view the mock, because for many people the mock is not still visible for the intern.
Yeah, I will ask and let you know.
Thank you, ma'am.
Ma'am, next
Yeah.
session is taken by TA,
Yeah, it is a mock discussion, so it will be taken by a TA.
but you explain better, ma'am.
Okay, I will see if possible. I might come.
Yes, ma'am.
Yeah, anyway, there are chances that it might be my last class, so all the best for your exams. Do well.
Thank you, ma'am.
Once you see a question paper, don't get too tensed because all the questions can be solved by you. So just be calm and just go through the questions with patient mind and try solving it because all the questions are easy. Only it was made to look complicated. So yeah. Sonali, what is the question number? Is it graded assignment or practice assignment?
It's a grade assignment, ma'am.
Graded assignment question number 6, right?
7.
7. Okay. Okay. 1 second. Okay, week 9 has not been uploaded yet, right, in the portal? Okay, from week 9, I think I haven't uploaded. So this is the question, right? Is my voice clear and audible?
Yes, ma'am, you are audible.
Yeah. In the given figure, the initial voltage across the 30 millifarad capacitor is 0 volts. Switch 1 is closed for a long time. Uh, and it is opened at t is equal to 0 and switch 2 is moved from position A to B. Okay. Okay, first we will draw at before t is equal to 0. My circuit is like this. Three ohm, 9 ohm, 1 ohm, 20 millifarad, 20 volts. Okay, switch 1 is closed for a long time and it is opened at okay after time t is equal to 0. My circuit will become like this: 9 ohm, 1 ohm, 30 millifarad. So uh, switch 1 is open closed for a long time.
Ma'am, can't we directly do this
Yeah,
like
that's what I'm saying.
voltage division method, like 9 upon
Mm-mm.
9 to 3 into 20?
1 upon, yeah, to find the, okay, 1 second. What is the initial voltage across the 20 millifarad? That's how they did, right? To find the voltage across the 20 millifarad is same as finding the voltage across 9 volt.
Yes, ma'am.
Hmm. What will I
Because
get? 9 by 12 into 20. This is 3 by 4. This is 5. This is 15 volts. Uh, this 15 volts will be used to charge this. So after a long time, this will become 15 volts. So the
Ma'am,
first
but we
question's answer
have
is
one
15 volts.
but we have one resistance there.
But what is the characteristics of that resistor there? See, this is similar to this. No, see here 15 volts is there. One R is there. One C is there. Initially, it will be like from 0, it will be going to 15 volts. No, that's how the step input will act, right? This R will determine how fast it is reaching. Whereas as time goes on, this R will be like decreasing like this. We saw till now, right? After a very long time, see, first I found the voltage across these 2 points, that is 15 volts. Then this situation will remain for a very long time. This is similar to finding, see, this is a step input Vm, and we are going to find Vc of t. Vc of t formula is Vm of 1 minus e power minus t by Rc. Here, if you apply e minus infinity, it is still Vm, right? This R
Yes,
will
ma'am.
not have any effect on this. So yeah, that's why here we are writing it as 15 volt. Then what is the final voltage across the 30 millifarad? Uh, okay. Yeah, okay. Okay. This diagram I drawn it wrong. This 20 millifarad is actually connected with this 30 millifarad. And the 20 millifarad will have 15 volt initially. Now we are supposed to find the final voltage. Here we are going to use charge conservation. Q initial is equal to Q final is a formula we'll be using. Q initially is nothing but 20 M into 15 volt plus 30 M into 0 volts is equal to 20 M V final plus 30 M into V final. Q is nothing but CB. Q initial is nothing but the initial capacitance into initial voltage. In 20 millifarad, it is 15 volts. In 30 millifarad, it's actually initially it is 0 volts. Whereas Q final, both will be reaching equilibrium and will be reaching a common voltage VF. So that's why here I am writing 20 M into VF plus 30 M into VF. So VF will be equal to 20 M into 15 plus 30 divided by 50 M. So if you solve, I think you'll get this value. What is the answer you will get after solving?
6.
3 and... Yeah, what is the answer?
6,
6.
6.
Okay, 6. Yeah. Then the ninth question is, E initial is the initial energy. Then E final is the final energy. Yeah. Mm, E initial is equal to half CV square. Here I also initial, V also initial. E final is equal to half CF VF square. Half C1 is nothing but 20 M into 15 square plus half 30 M into 0 square. So half 20 M into 15 square will be my 1 E initial value. My E final value is nothing but 1 by 2 C1 plus C2. 20 M plus 30 M. VF is nothing but 6 square. So this is my V final. So divide this value by this value. What is the value that you get? 15
2 point,
square. Yeah, you're getting 2 point something, right?
2
I think
point.
you'll get around 2.5. Yeah, so now is your doubt cleared?
No.
Okay.
19 PA. Practice assignments week 9.
Okay. Question number? Okay, this will be the last question. Question number?
19, ma'am.
19, okay. Yeah. Yeah, in the circuit shown below, switches S1 and S2 are initially closed. That means, yeah, my circuit is like this: 5 volt, 2 microfarad, then 1 microfarad. Okay, like this, 10 volt, right? So actually, this is case 1, where S1 and S2 are initially closed and S3 is open. Now S1 and S2 are open. Then my circuit will become like this, right? Case 2. So due to this, the voltage across here will be 5 volt and here it will be 10 volt. So the initial voltage is 5 volt here and it is 10 volts here. We have to find the final potential difference. Here also the charge conservation will use. Q initial is equal to Q final. 2 micro into 5 plus 1 micro into 10 is equal to 2 micro plus 1 micro VF. So V final is nothing but 10 micro plus 10 micro by 3 micro. So it's basically 20 by 3. You will get around 6.67 something and 6.67. Is it
Ma'am,
clear?
in final volt, we will not consider
Will not consider.
all the
Hello?
capacitance in the circuit.
Yeah, we are considered, no? See the case 2 micro and 1 micro. What's the doubt? I'm not understanding.
Yeah, got it.
Yeah.
Ma'am, when we use that charge initialization formula,
Yeah, see, they are, if they are asking the potential difference, if they are asking to find the potential difference across some voltage, then we use this charge like conservation formula.
yeah,
What happened? You're telling something?
no, ma'am. I am wondering in the pronunciation of initialization, so I am checking on myself.
Okay, okay.
Thank you, ma'am, for taking such a wonderful session, ma'am.
Thank you. I hope you all get good marks.
Yes, ma'am. Thank you.
Yeah, thank you. Yeah, thank you guys. We will end today's meet.